Hello, good morning, everyone, and welcome. Thank you for coming to our talk. Today, we're going to talk about two very highly requested user features, which are new in Android Q, and that is dark theme and gesture navigation. My name is Nick Butcher. I'm an engineer on the Android Developer Relations team.
My name is Chris Baines, and I'm also an engineer on the Android Developer Relations team.
And I'm Rohan. I'm a PM on the Android System UI and Launcher team.
We've got a lot to cover today, so let's get started. First up, we want to talk about dark theme. Wait, that's better. Dark theme. So why is dark theme important? We think there's three major reasons. The first up is supporting using your applications in darker environments. How often have you used your phone in a darkened room and been blinded by a bright white screen, which is not what you want? Supporting a dark theme enables usage of your app in many wider situations. Secondly, we've seen, by lighting up less pixels on the screen, we've seen significant reductions in power usage. In fact, in our tests, we've seen up to 60% reduction in power usage when the app is in the foreground, which can be a real user benefit. And lastly, dark themes can support accessibility while maintaining sufficient contrast ratios. They have less eye strain on the user, so they can be used by certain classes of user much more comfortably. So, for those reasons, we've introduced a new system setting in Android Q. So now, under the device's display settings, you can choose between a light or a dark theme. You can also use the new quick settings toggle to quickly flip between those modes, and the device will automatically kick into dark theme when your device enters battery saver. Now, it's important to note that dark theme is actually a system-wide setting, not just for the system UI, but it applies to all apps running on the device. And as such, we think that users are going to increasingly expect your applications that you're writing to respond when they set this system toggle. So here, for example, I've got two apps running in split screen, and when I toggle into a dark theme, we can see that only one of them responds. And we think the users are going to increasingly expect your application to follow this. Now, I've picked on Google Drive here because they're not currently supporting dark theme, but all Google applications are actually committed to update to support dark theme by the time Android Q rolls out. So this is only going to increase the user expectations. So as such, we strongly recommend that you look at supporting dark theme in your applications. Now, we recognize that that's going to be some work for you developers, us developers. And so as such, we're introducing something new in Android Q, which is a feature called Force Dark. Now, Force Dark attempts to automatically apply a dark theme to a light theme application. It does so, well, let's take a look. So here's the Google I/O application, and here it is with Force Dark being applied to it. And it does so in a kind of intelligent way. It runs at rendering time, and it actually inspects the views that it's rendering and tries to smartly work out which ones should be inverted in order to run dark. It even does some clever stuff, like looking at bitmap drawables, and tries to work out if there's a variation in the hue. Is this some kind of photographic data, and not invert certain kind of images? So it's got some smart heuristics in it. Force Dark is opt-in. You have to turn it on for your application, and you do so like this, by setting Force Dark allowed to true. Here, I'm setting it at the theme level for my entire application theme, so it will apply everywhere throughout the app. But you can choose where to turn it on. So you could turn it on just for one or two activities and use it almost as a kind of migration to help you rapidly adopt a dark theme. So Force Dark can help you to rapidly adopt dark theme, but we still actually recommend that you look into designing a custom dark theme, which you can do so using themes and styles. The reason for this, well, there's two main reasons for this, really. The first one is that Force Dark is only available on Android Q, so it's only going to benefit users on Q Forward. Whereas implementing a custom dark theme is actually using standard Android styling techniques. You can roll out your dark theme to all kind of major API levels. The second reason why we think it's important to go custom is it gives you utmost control over exactly how your app renders, which is what you want, right? You don't actually get to hook into how Force Dark will darken your application, so how it will change the colors. So if you want control over that, if your designers want to be able to control the exact shade of blue that the fab here is going to change to, for example, then a custom theme is the way to go. So to help you to design for dark themes, we've just released this week some updated guidance on the material.io website, which covers how to generally design a dark theme application, with specific guidance around important areas such as accessibility, and guidance on how to adapt your app's color system to work under a dark palette. In fact, there's another session at Google I/O right after this one on stage 1, which is all about how to design for dark theme. So to implement a dark theme, we recommend that you take a look at the AppCompat and Material Design Components libraries, which Chris is going to talk about now.
Thanks, Nick. So day-night is a feature in AppCompat which you've had for a number of years now, which allows you to easily implement one of those custom themes in your app. Now, the way it works is by enabling the night resource qualifier, and it works back to API 14, which is Android 4.0. We've been hard at work over the past couple of months to improve it, and that is available in AppCompat 1.1, which is available now. To implement a theme using day-night, the first thing you need to do is to change your theme parent to be one of the theme.appcompat.daynight variants. If you're using Material Design Components, which I'd recommend you do, it also provides a day-night theme in its version 1.1, again, available now. As we mentioned earlier, AppCompat enables the -night resource qualifier to work, and that is exactly how the theme is implemented. You can see in our default configuration that day-night points to theme.appcompat.light, which means that when the light theme is selected, we'll use a light theme. And when in our night configuration, in values.night, it points to theme.appcompat, which means we'll go dark. The next thing you need to do is tell AppCompat what mode to use. Now, we have 2 APIs for that. The first is set default night mode, which is used when you want to set a mode across your entire app, so all of your activities. If you need a local override in a specific activity, we have set local night mode. Now, one thing to note is that the values you set on these APIs are not persisted, so therefore you need to use the method whenever your app process is brought up. Usually you'll do this in your application object. Using those APIs, you need to give it a mode, and we offer 4 main modes. The first is mode night yes, which means always dark. Mode night no, which is always light. Follow system, which will follow the current system setting. Now on Q, because we have a new system setting, which is great, it will do that basically. Whenever the system setting is changed, your app will follow it. And when you're running on devices before Q, so Pi or earlier, it will usually default to a white theme. The next new mode is called Auto Battery, which we've added in AppCompat 1.1. And that goes dark whenever the battery saver feature is enabled, and it works back to API 21. So here you can see an example where a device is going into battery saver mode. When that happens, your app will automatically go dark. When the user plugs the device back in, so it goes back to charging, and therefore we leave battery saver mode, like so, we'll automatically go light again. The final thing to check is to make sure that your activities are extended from AppCompat activity. This may sound super obvious, but it's something which is easily forgotten. So as I said earlier, we've been hard at work over the past couple of months to improve the day-night feature. And so I'd like to take you through some of the things we've done. So one key change is that set default night mode now recreates any visible activities. It previously didn't do this, and you had to do all that work yourself, whereas we now do it for you. We also had an incompatibility with WebView, whereas if you're using day-night and then later inflated a WebView, we'd reset the theme, and then things would go very wrong. And that's now fixed. The final thing is that mode night auto time is now deprecated. As said earlier, we've been hard at work over fixing many, many bug fixes, which you have all raised. So hopefully, if you've had any issues, they're fixed. And that leads us into an app theme setting. So to support user customization, we recommend providing a way for users to choose the theme that they want in your app. An example could be an ebook reader. If the user knows that they are always going to use that app at night and they always want it to be dark, you want to provide a way for the user to select that. We recommend there being 3 options when running on Android Q: light, dark, and then system default. System default being the default option for your app. If you're running on Android P or before, because we don't have that system setting, the options are slightly different. They're now light, dark, and set by battery saver. Now, the keen-eyed among you will notice that those options map pretty directly to some of the app modes, and that's totally on purpose. There's a one-to-one correlation between those options and the modes we actually have and we offer you. So now I'm going to hand over to Nick to talk about how elevation works with dark theme.
Elevation. So in material design, elevation is a key concept for showing the importance of some content in your application by changing the elevation of the surface, and for hinting at interaction cues. Now, in light themes, this is represented with a shadow, and as the elevation raises up, the shadow becomes more diffuse. But when you have a dark background, like in dark theme, this can be harder to see. And as such, we're introducing the idea of elevation overlays. The idea here being that as the surface raises up to get closer to the virtual light source, the actual surface color itself changes, as if there was a semi-opaque white layer on top of it, which gets more opaque as we raise up in elevation. Don't worry, we're not actually doing overdraw of a white layer on top. This is actually, we kind of blend down the color and use it as a tint on the background color. So to use elevation overlays, then all of the components in Material Design Components version 1.1 onwards will support this out the box. These are the components which use the color surface attribute for their background color and support elevation. And as such, just by setting the elevation on the components, you'll get this surface overlay behavior. But if you want to build this behavior into your own custom components, there's a couple of options. Firstly, you could use the material shape drawable, which is the kind of background drawable which powers a lot of materials shape theming as well as this material elevation overlays. And you can use these in your views as well. It's been augmented with new APIs such as create with elevation overlay, or set elevation or set translation Z, which will give you this overlay behavior. If you can't use the material shape drawable for some reason, you can instead take a look at the elevation overlay provider class, which is what material shape drawable uses under the hood. This gives you lower level methods such as working out the surface color for a given elevation, which you can then use in custom drawings, say. Now, implementing dark themes, as we said, comes down a lot to good hygiene with your application's themes and styles. And we'll give you some specific tips and gotchas when implementing dark modes. Quite commonly, we've seen an issue where applications which are designed like this for a light screen, where they might have dark text on a light background, when they apply a dark theme to the app, see an issue like this, where you end up with, say, dark text on a dark background, which you end up not being able to read. Or perhaps the text correctly inverts to light, but your background remains light. So these are common issues that we see in applications supporting dark theme. And generally, what this happens is you've made some assumption that somewhere in your layouts about running under a light theme, and you've kind of hard-coded some colors, like hard-coded a white background or black text in this case. Now, you're probably not hard-coding things like this in your layout, but you're probably using some kind of color resource, and this is essentially the same. If you only provide a color value in the default configuration, this is essentially the same, that it's not going to respond when running under dark theme. What you need to do is provide an alternative color when running under the night configuration here in the values-night folder. And as such, these colors will then respond to the theme change. Better yet, you could take a look at using theme attributes. Theme attributes are essentially semantically named colors which have different values when running under a light or a dark theme. So here, for example, I'm changing that hard-coded background from white to materials color surface color, which is a kind of good background color. And so that will flip from white in a light theme to a very dark gray when running under dark theme. Or likewise, I'm using the platform's text color primary here for the text color, which will give you the inverse of that. So it will be dark in a light theme and light in a dark theme. In fact, if you take a look at the material color system, it has lots of these semantically named colors, which are super useful to be for using in your designs. So you're probably familiar with things like color primary, color secondary, color accent, and so on. But here's the surface color that we looked at before. But they also provide a series of on colors, so colors which will contrast on top of the relevant color. So on primary, on secondary, on surface. So, for example, the on surface color is a color which will always contrast on top of that background surface color. So we can use this in combination with a neat trick that color state lists provide to great effect during dark themes. So for example here, I'm using the fact that color state list lets you separate out the color from the alpha channel and define them separately. So I'm grabbing the color on surface, so something that will always contrast the surface color, and applying an alpha modification to it. So this can be super useful if you want to avoid having 50 different shades of gray in your colors XML file that you're scared to kind of update because you don't know where they're going to use. Instead of that, if you can reference these colors always guaranteed to be the right color to contrast given a different theme, and just apply an alpha modification, it can be super useful. One caveat is this alpha kind of modification was introduced in API 23, Marshmallow. So if you want to use it beforehand, make sure you're using the app-compat resources path or loading it like this in code. Similarly, whenever you're loading colors in code using context.compat.getColor, for example, be wary that you want to ensure that those colors as well have night configurations. Or better yet, you might want to do something like this code here, which is querying the current theme for a theme attribute. So this is how you can get access to something like text color primary or color surface in your code. Another class of issues we've seen is around drawables. So if you have drawables, you probably want them to be like showing up like these light drawables here, but you might encounter similar issues as we saw before, where you might end up with dark on dark. Or you could look at providing completely separate versions of the drawables under the drawable-night configurations. A better way is actually probably to look at tinting, because usually these are like monochrome icons that you just want them to change the entire color of them. So you can tint at a couple of levels. You can either tint at the view level here. So here I am going to tint whatever the drawable's given me with whatever color secondary is for the current theme. So we'll update it depending on the theme. Or hopefully you're using vector drawables throughout your app for your assets, which natively support tinting on the root element of the vector. So here I'm setting the color control normal theme attribute, which is the standard kind of gray icon color. So setting this means your icons will always be the exactly right color. Or if you're working in code, you could also use the drawable compact class, which can apply a tint dynamically to a drawable as well. And lastly, it can be handy to work out if you're running under currently running under a dark theme, which you can do with some code like this, which actually looks at the configuration's UI mode and checks whether this is currently in night mode. So this is useful for querying whether you're under a night mode and maybe branching your logic or setting a different tint on a drawable or some such. Those were just some quick tips about working with themes and styles. We could spend a whole talk talking about talking about themes and styles, but we've actually already done that a couple of times. So I highly recommend you check out these resources on that. Lastly, I want to revisit ForceDark and talk about how it can help you to migrate to a dark theme. So here's an application designed for a light presentation. And when we apply ForceDark to it, we can see it's generally done a pretty good job of it. Right? It's generally inverted a lot of the colors. But there's a few opportunities it could be better, in my opinion. In fact, if we compare it to a custom dark theme, which I designed, you can see a few things which ForceDark hasn't gotten quite right. For example, if we zoom in on this drawable on the left, which is indicating the depth of a threaded conversation, ForceDark has made it a bit too light for my taste. What you can do in these situations is you can set ForceDark allow to false on any given view or view group and disable the ForceDark behavior just for that part of the hierarchy. But remember, when you set ForceDark to false, the general configuration is still running under the night mode. And as such, we can use things like tinting, and this tint color will give you the right color for a theme. So this will respond to the night configuration. So check out ForceDark. Like I said, it's one-line change in your theme to set it for your application. Or we've actually introduced a new developer option where you can force the entire device into this ForceDark mode. So if you want to check it out now, if you're running beta 3 or newer, you can see how your app responds to ForceDark. So next up, Chris is going to introduce some common scenarios we've seen with dark mode.
Thanks, Nick. So the first thing we're going to talk about is web content. Now, the good news is that WebView works seamlessly with ForceDark. So if you're opted into ForceDark when you're running under a queue, and you have an example here. So we have an app here which is loading google.com in a web view, and we've enabled ForceDark on this app. And when we go into night mode, it changes the web view content as well. It also works in Chrome, Chrome-based browsers, and WebView. So soon, actual web content will be able to support dark theme natively using a new CSS media query called prefers color scheme. We've also added dark theme support in custom browser tabs. And by that, we mean the UI around it. So we have a new method on custom tabs intent called setColorScheme. It takes one of these three options. Now, here we're in light theme, but when we go to dark, it looks a little bit like this. Now, you'll notice that the content itself doesn't have ForceDark applied or anything like that. That's because we're relying on the web content itself to use that media query we just spoke about. Now, MapView itself doesn't support dark theme out of the box, but we can easily make it do so by using its custom map styling functionality. Now, custom map styling allows you to specify the colors and text and stuff of a map via a JSON file. You can see a link to a website where you can actually download some map styles that we provide for you. I think there's 9 styles on there. Some are light, some are dark, but you can also customize it to your needs. Now, we can actually use that feature by using the -night resource qualifier that we spoke about earlier to make map view support dark theme natively. So in our default configuration, we'll put a light-styled map in the JSON file in res-raw. And then in res-raw-night, we'll put a dark-styled JSON file. And that way, map view will automatically load the correct map style and then use the correct colors.
Another issue we're seeing when adopting dark themes is with illustrations, which you're probably using in kind of empty states or maybe onboarding flows in your applications. If you just use the same illustration designed for a light theme and under a dark theme, you can see too high contrast, where these colors are like way too saturated and they contrast very highly on these darkened backgrounds. We recommend that you provide an alternate version when running under a dark theme, which is more harmonious with the kind of darker background. Now, again, you could just provide an alternate version of this drawable, so you have 2 versions of very similar drawables in your application. But a better way to do this might be to use Vector Drawable's ability to reference color resources for individual fills or strokes of paths. And as such, you can vary just the colors when running under a night configuration. So this way, you only have to ship one version of the drawable, but have the colors respond to when it's running under a dark theme. Next up is notifications. So notifications when running under a dark theme will respond and go dark. So if you're using any of the notification templates, these will work just out of the box. But if you're using a custom layout, if you're setting a custom layout, then all the rules we talked about before about styling still apply. So don't assume it's running under a light mode, don't hard code colors, use theme attributes. In fact, I'd encourage you, if you're styling any text in particular, to look at the subclasses of the notification text appearance, so that your text will mirror that of the system's notifications as well. So that was dark mode. Our takeaways really are that users are going to increasingly expect your applications to support dark themes, so really do take a look at supporting it as well. Use AppCompats, day-night, and material design components, which have lots of built-in support for implementing this in your applications. And be sure to look for these latest versions, these 1.1.0s, because there's been lots of improvements and bug fixes in them. Consider ForceDark as something to help you rapidly adopt a dark theme, and maybe use it as a migration tool so you can enable it for certain activities and then roll out custom themes gradually. And theme attribute all the things. Don't think about being hard-coded in a single configuration, a single color scheme. Be very flexible. Whenever you see a hard-coded color or a color resource with only a single version, see that as a red flag. So now I'm going to hand over to Rohan, who's going to tell us all about gesture nav. Cheers.
All right, so I have the benefit of telling you all about gesture nav. A few of you might have played with it already on beta 3. If you haven't, make sure you give it a go. It's out there in settings. You can search for fully gestural navigation. But I'll do a quick refresher of what it looks like right now in Android Q. So we're adding a new nav mode, if you haven't already heard, in Android Q that replaces the beloved 3 buttons with 3 glorious gestures. And here's what they look like. On the left, you can see that swipe up from the bottom will become the gesture for home. Swiping up and holding in the middle will take you to your recents or overview. And on the left, you can see that swiping in from an edge will take you back. Now, the one thing that this movie doesn't really do justice is that we're also introducing swiping left and swiping right in order to go back. We think it's a super awesome experience. Internally, we love it. We've heard really great feedback. We definitely want to hear how you feel about it. But definitely give it a try. So a big question we've gotten is, we're introducing another nav mode in Android. What do we do? Like, we're developers. What are you trying to do in Android? So I want to talk about that a little bit really quickly. In the future for Android, we're going to be supporting 2 nav modes moving forward. The first one is 3 buttons. Android users love 3 buttons. We know that it's super usable, and it also addresses a lot of accessibility needs that gestures just cannot. On the other hand, we also know that there's a lot of desire for gestures. So we will be supporting 1 gesture mode, which is what you saw, moving forward in Android, and only that one. I want to take a quick step back and talk about why we're doing this now before we dive into the details for developers, and talk about user trends here. So Dan Sandler talked about this in his talk in What's New in Android, but users increasingly want immersive experiences in Android. And one thing that device makers have done is try to approach this from a software side. And what they've done is built their own gesture nav. And every device maker has a different impression of how gesture nav should work. What we recognize on the platform side is that kind of gets insane for a developer. Thinking about n different gesture navs when you're trying to develop, just design for, test for your app, just kind of gets insane. So with that in mind, we introduced this gesture nav in Q, and we're going to be standardizing the ecosystem as of Q on 3 buttons and our model moving forward. And just want to elaborate the problem here. There's a lot of different gestures. These are just some of them. Dan's talk had different swirl gestures, and maybe a knock-knock does something different. But we do want to unify that core set of gestures, back, home, and recents. Taking a slightly different spin on this, why should you care as an app? I'm going to regurgitate that immersion bit, but flipping this a little bit, there is an opportunity for you as an app to delight your user by bringing this immersive experience to your app and making sure that it's compatible with this new nav mode. In terms of compatibility, we recognize that there may be some conflicts that you will need to handle as an app, and we'll talk about that coming up. Cool. So how do you make your app nav ready? And nav just means any nav mode, 3-button gesture nav. How do you prepare for this immersive experience? And more importantly, how do you prepare for gesture nav? There are 3 things you need to do. The first one is making sure that your app goes edge to edge, which Chris will explain a little bit more. The second thing you need to do is leverage insets, old insets and new ones that we're adding, to make sure that any kind of critical content is in a safe place and is in optimal positioning. And the third and final thing is handling conflicts. If you do have a conflict, how do you handle it, and how can you override certain gestures so you can bring a better, delightful experience to your app? Cool. So I'll hand it over to Chris to talk about edge to edge.
Thanks, Rohan. So what is actually edge to edge? Well, let's take a look at a typical app when you're running Android Q today. So here you can see that the bounds of the app are actually below the status bar and above the navigation bar. So what do we want on Q? Well, simply, we want the navigation bar to disappear, allowing your app's content to be displayed behind it to create a more immersive experience. And when it scrolls, it looks a bit like this. So as a recommendation, drum behind the navigation bar is now strongly recommended on Q. It's optional before Q, but one thing to note is that a lot of the APIs and how you do this actually works back to previous versions of Android. So if you're going to put the work in for Q, it's not that much more work to do it for pre-Q as well. Now let's take a look at the status bar. Now similarly, we actually want the status bar to go away as well. Again, allowing your app content to be displayed behind it, creating a more immersive experience. And you'll hear the word immersive a lot in this presentation. So now our app looks a little bit like this when it scrolls. And again, drum behind the status bar is now recommended on Q and optional before Q. So if we take a look at our bounds, they've come from here to here, which is where we get edge to edge from. So let's take a look at now about how you actually implement this stuff. So the good news is that from Android Q onwards, the system is now responsible for recoloring the system buttons and the handles. So you can see here an example where as we scroll, that navigation bar handle at the bottom is changing color based on the content behind it. Now the recoloring can take the form of both dynamic color adaptation, which you've just seen, or it could be static coloring on less powerful devices. When you're running on older platforms, because that recoloring doesn't happen, we recommend that you set a translucent navbar color so the user can actually see those buttons. So to really make your app go immersive, there are 3 things you need to do. The first is change your system bar colors. Second, request to be laid out full screen. And then the final thing is to avoid any overlaps with your views with the system UI. So let's go through it. The first one is to change the navigation bar color. Now we have this attribute available in Lollipop onwards, which we can use, and we're just going to set it to transparent. When you run on Pi or before, you should use a translucent color, as we just mentioned. The next thing we need to do is request to be laid out full screen. Now we're going to use the infamous set system UI visibility method with a number of flags. The two flags we need are flag layout hide, and that tells the system to lay us out as if the navigation bar wasn't there. And the second is layout stable, which is a special flag that tells it to lay us out at our most extreme. If you also want to be displayed behind the status bar, there's an additional flag you need to use called layout full screen. Now, when we lay that full screen, we don't want our views to be displayed behind the system bars, and that is where insets come into play. Now, insets are a collection of values which tell you how much to move or inset content by. Now, what views you move, how much you move it by, depends on the inset and its purpose. Now, you might have seen the window insets class. There are a number of types of insets. The first type are called system window insets, and they tell you where the system UI is being displayed over your app. They are commonly used to move views so they're not obscured by any of the system bars. So here you can see a fab at the bottom right. So if we blow that up a little bit, typically a fab will have a 16-dip margin applied to it. And you can see that they are denoted by these blue bars. So actually, in gesture nav, it's not too bad. It's only obscured by the bottom 2 dips or so. So we'll use the system window inset to actually move that up. But in free-button navigation mode, it's actually a lot worse. Because the navigation bar is taller, our fab is a lot more obscured. So by using the system window insets, we can move that up and make sure the user can actually click it. So as a recap, system window insets are used to move clickable views. The next type are called system gesture insets, and they're new in Q. Now, they represent the areas of the window where system gestures take priority. Visually, they look a bit like this. So let's go through them. They include the vertical edges for the back gesture. So if the user starts dragging from anywhere in the left and the right-hand zones, the back gesture will start triggering. And again, on the bottom side, where the home gesture takes place, again, if the user starts dragging there, the home gesture will take priority. Now, as mentioned, system window insets were used for clickable views. System gesture insets are used for draggable views. We'll go through an example a bit later. The next and final type are called mandatory system gesture insets. And they're a subset of system gesture insets which define the areas which cannot be used with the exclusion APIs, which Rohan will talk about in a minute. Now, in Q, they are currently only used by the home gesture, because that's a protected gesture that users should always be able to exit your app. Over to Rohan. Oh, no,
right.
Maybe not over to Rohan. So as a quick overview, system window insets are clickable, gesture insets are draggable, and mandatory system gesture insets are used to check for the exclusion APIs. I'm actually over to Rohan.
There we go. So the third and final thing in making your app nav ready is overriding system gestures. So Chris already talked a little bit about some of those system gesture insets and ones that are mandatory, but I want to quickly talk about what kinds of conflicts you may have to handle and where you may need to override. So any sort of horizontally draggable content that resides in those back zones within those system gesture insets is an area where your app may have conflict. I want to give a quick example here, but I opened up a photo in the Photos app, and I wanted to crop a picture and crop my buddy out. And you'll realize that the crop handles, the little circles you can see on each corner of that square, are awfully close to the edge. And unfortunately, those are in the system gesture insets and in that back zone. So there are other examples like this, with sliders, seek bars, video seek bars, for example, other drag handles, etc., that your app may need to be aware of. Great. So how do you override some of these gestures? How do you make sure that your user is able to use those crop handles, etc.? So there is a new API available in Q that will allow you to opt out of at least the back gesture. Home is still a mandatory area. We know that's the only way a user can leave your app, so we're not making that opt-outable. But basically, how the API works is that you can specify rectangles on screen where basically you'll get touch events instead of the system consuming it for back or for any gesture in that area. One quick word of caution, this is pretty powerful. One quick word of caution here is that be really careful when using this. Users expect to be able to go back. It is one of the most frequently used system actions. I think it's used twice as much as home. And if you suddenly break that and decide to take over the entire edge, for example, your users might get frustrated. So be really careful when using this, and make sure that you have very clear visual affordances, such as the drag handle, that indicate that you can actually swipe there, and a user will start interacting with app content instead of going back. Taking a quick look at the API, it's going to be in the view class, and it's called set system gesture exclusion recs, and it takes in a list of rectangles where your app will get the touch events first and only. You can use this in on layout if you have kind of static content that isn't really shifting, or you can set this in on draw if you want more kind of real-time frame-by-frame updates. Cool. So let's talk about some common scenarios with all of these 3 pieces of guidance, and Chris will take over here.
Thanks. Right, so the first scenario we're going to look through is scrolling views. Now, as you can see here, content should be drawn behind the navigation bar as the list scrolls. But when the user reaches the end of that list, that final item should still be above the navigation bar, allowing the user to interact with it. As you can see here, when we reach the end of the list, we still want those bottom items, lightning talks in this instance, to still be above the navigation bar so the user can interact. So a common way to achieve this would be through padding, and we'll pad our scroll and view using the system window insets that we spoke about earlier. Here's a quick code example. We'll set an onApply window insets listener, and then we'll wait for some insets, and then we'll just set the padding on the scroll and view, in this instance, the recycler view, using the system window inset padding. And the final thing we need to do here is something called clip to padding. Now, by default, whenever a view group sets padding, or has padding set on it, it will clip its children. Now, that's because that's the whole effect we want. We want our children to be displayed behind our padding. We need to turn that feature off. So recycler view, list view, and all the other scroll and view support this, so we just need to set it to false. The next scenario is all about navigation draws. Now, if you've tried beta 3, you'll probably have noticed that a lot of apps use navigation draws, and it can sometimes get a bit funky. So draw layout will automatically exclude the correct edges as necessary. So here you can see in the Google I/O app that when the drawer is closed, it will open, and then the next gesture, when it's open, the back gesture will actually take preference. Now, to use this, you need to update to 1.1.0 alpha 1, which was released this week. For bottom sheets, generally we want to avoid views near the vertically scrolling gesture zones. But bottom sheets are obviously a pattern which a lot of apps use. So for collapsible bottom sheets, we want to make sure there's enough content above the navigation bar for the user to be able to actually drag it. So here we're looking at an example where we haven't done that. And you can see that as the user tries to drag the bottom sheet, actually the home gesture is going to take over. Now, we don't want that, obviously. So one way we can get around it is by using the system gesture insets to increase our content size, allowing enough space for the user to actually drag it. As so. So in terms of code, here we're using the bottom sheet behavior from materials line components, and it provides peak height. So that's the amount of height available when it's collapsed. So here we're using onApply window insets listener. We'll grab our system gestures, and then we'll just increase that peak height. Now, it's also available in ViewCompat in the core library in Android X. And again, we've released a new version this week called 1.2 alpha 1. But remember, users can always swipe to go home by swiping off the bottom of the screen. So even though we've done this and we've moved the peak height up, users can still accidentally trigger this gesture. And that's obviously annoying for users. So draggable content near the gesture nav zone is possible, but be careful if you're going to do it. One thing also to say is that try and make the draggable content more obvious to the user so they drag the right bit. So here you can see that the actual header bar is fully opaque. The content below it has an alpha effect applied, trying to guide the user to the top section. The next scenario is carousels. By that we mean view pages or any horizontally scrolling lists like recycler views. Now, one thing we don't really want is for apps to set exclusion recs everywhere, because that's a problem for users. If an app sets exclusion recs all across the left and right zones, the user's not going to know where they can actually trigger back. And the final scenario is all about landscape. So if we've gone edge to edge, what we talked about earlier, in landscape, when in button mode, what we'll actually get is this, which obviously isn't great. So you can see that the button options are actually obscured by our app's content. Now, this doesn't happen on gesture mode. It only happens on button mode. So if you have text which starts near a vertical edge, think about padding all of the content in horizontally. And one thing to note also is make sure you test your apps both on button modes and also the gesture nav modes. As a code example, it's pretty easy. You just need to find a view somewhere in your activity near the top, set an on-apply window insets listener, and then set the left and right padding based on the system window insets. And that's safe to use in all orientations because it will always give you the right values. And once you've done that, it'll look a little bit like this. I just want to say, we are adding more support in our Android X libraries, Jetpack libraries, to make this a lot easier for you. The examples we've just gone through are just trying to show you how we've tried to implement this in our libraries. But if you have custom views, obviously you're also going to need to do something similar. Now, if there's difficult patterns that you're finding, please raise them so we can try and build better support for you via the bug tracker. So as a quick TLDR, users will expect apps to work on all navigation modes, so please support it. Try and create immersive UIs, because it's giving you, your apps, more real estate to display in. Proactively update the Jetpack and MDC libraries, because we are going to add more support as time goes. And only use the gesture exclusion APIs if you really need them. They're really meant as an escape hatch for your apps. And finally, let us know about troublesome scenarios via the issue tracker we just spoke about. And thank you very much.